Right, now we're getting into the good stuff. So simple interest. Right, if you deposit money into a bank, the bank is borrowing money from you. So the bank will pay you a fee for using your money, and this fee is called interest. Alright, or simple interest. Simple interest is a special case of growth in which the starting value, remember starting value is V0, is the amount borrowed or invested. Right? So let's say I go and I deposit $1,000 into a bank account. Alright? The bank will pay me a certain amount of interest at regular periods. So they may pay me 10% per year. Alright? Or they might pay me 5% per year. Right? It depends on the loan, but they will pay you a certain interest rate for borrowing that money. A recurrence relation can be used to model the investment of the loan and to find the value of the investment from year to year. So the formula or the recurrence relation that we use for simple interest is VO, the principal, so the original amount you invest. Like I said, I might have invested $1,000. And the rule, Vn plus 1, is equal to Vn, the current term, plus our difference, right, or D, where D is equal to R, the rate, so that might be 10 or 5%, right? So it might be 5% divided by 100 times our initial amount, our investment, so $1,000. Let's have a look at an example. Right, modelling simple interest with a recurrence relation. So Cheryl invests $5,000 in an investment account that pays 4.8% per annum, so per year. Per annum means per year. Simple interest. Model this simple investment using a recurrence relation of the form. So this is what we got given before. This is our recurrence relation for simple interest. All right, we need the principal, VO, and the rule. Vn plus 1 equals Vn plus D, where D is equal to the rate divided by 100 times our initial amount. Right, so first, what do we know? We know that our initial investment is $5,000. Now we need to find D. D, remember, it's equal to the rate. Our rate was 4.8% right, per annum, right, over 100 times our initial amount, which was $5,000, right, which is equal to 0.048 times 5,000, which equals $240. Right, that is not our final answer. We need to write it in the form, so model it as a recurrence relation. So remember, VO is equal to 5,000, comma, Vn plus 1 equal to Vn plus 240 from down here. And that's how we model it. Now the next question B says, what will the value of the investment be after 3 years? Now we can use our calculator in the way that we did in the last topic of recurrence relations, right? But we can also model it using our recurrence relation. Now, we know that our rule was V0 equals 5,000, so this is our recurrence relation, Vn plus 1 equals Vn plus 240. Right, so our year 1 is going to equal our Vn plus 240, where our current term is our initial term, 5,000 plus 240, which is going to give us $5,240 after the first year, or at the first year. Our second year is going to be Vn plus 240 again, right, where Vn is our previous term of V1, so 5,240 plus 5,240 equals 5,480. Right, that's our third term, and we want to know after 3 years, V3 is going to be Vn, so our current term plus 240, right, So 5,480 plus 240, and that is going to give us 5,720. Alright, so the value of the investment after 3 years will be $5,720. Remember, the easier way to model that is using your calculator. Right, so enter the initial amount and apply the rule, press enter 3 times.